Hi guys, today we're in section 9.2 and we're learning about the binomial theorem and Pascal's triangle. I'm not sure if this is something that you've learned before, but it goes with our probability that we learned yesterday with our NPR and NCR specifically. So if you are not comfortable with that, go back and check that out and review that before getting involved in this. Okay, so first thing to think about is binomial theorem starts with the concept of a binomial coefficient. So a binomial coefficient appears when you expand out an expression. So it appears in the expansion of a binomial being raised to a certain power. So we'll say a plus b raised to the n. And it is values of n choose r, where r equals 0 minus n. So let's write all that out. And our values of NCR, where r equals 0 minus n. So NCR is the most important thing we're taking out of this, is we use NCR for this. You notate it sometimes a different way. So sometimes it's notated as these parentheses with n over r. That reads the same thing as what I have squared above, n choose r. So those mean the same thing. They all go together. So it's a nice, fun little triangle we got going on there. And it's funny that I say triangle because I'm about to show you Pascal's triangle. This is just a kind of form, I guess, or a way to organize our thoughts. Pascal's a mathematician who came up with this a long, long time ago. We can probably already know a lot of these things, but it's nice to have a pattern to put it in. Okay, before we get into Pascal's triangle, though, I want to do a quick example. This is something that you should know. If I wrote like x plus y squared, would you know how to expand that out? You'd say, yes, Ms. White, of course I do. I learned that in Algebra 1 or Algebra 2, or whenever you learned it, I don't quite remember. If I have x plus y squared, it's the same thing as x plus y times x plus y. Once I get there, I'm allowed to what we call FOIL, first, outside, inside, last. And when I multiply those together, I get x squared plus x times y plus x times y, which will be 2xy plus y squared. When I'm talking about binomial coefficients, it's like these numbers that are in front of all of those terms. Okay, so Pascal's triangle is a way to organize the pattern that we find if we were to do all of these expansions. Okay, so we'll call this Pascal's triangle. Ignore the weird T. Okay, so the first one would be if I had x plus y to the 0. Well, anything to the 0 is what? 1. Very good. Now I'm going to do x plus y to the first. If we were to expand that out, it's just x plus y. So my coefficients would be 1 and 1. X plus y squared, well, we just did that out. You can see above for that. And so my coefficients there are 1, 2, and 1. We can keep going. X plus y to the third. We could work that out. But the cool thing about Pascal's triangle, and the whole reason we do this, is that it's lined up this way because we're going to use the lines above it to help us solve what comes next. So you always carry the ones on the outside. It always starts with a 1 and ends with a 1. But the middle term comes when you add the 2 that are on top of it together. So actually, let me center this 2 a little bit better. I lost this arrow. Okay, there we go. Okay, so the 2 comes from where I add 1 and 1 together. So if I was to continue this pattern for x plus y raised to the third, I would keep my 1 on the outside, and then my next term would come from the 2 numbers above it added together. 1 plus 2 is going to be 3. Same thing if I add now this 2 plus 1 together, it's 3, and then I have 1 on the outside. I don't know if any of you were ever in choir or band, but they always say like find the windows, be windows and doors. So we're going through all of the windows. You're not going to have anything stacked right on top of each other. Like there's a space between 1 and 2, and 3 goes like right in between it. That's why I have the arrows going together. Okay, we're going to go all the way up to x to the 5th. So we're going to do 2 more rows. If you think that you got it, I would pause this video and maybe try it on your own and then check back in. So I'm going to do x plus y to the 4th and x plus y to the 5th using my pattern. Okay, so I have my 1s on the outside. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. In the last row, the 1s go on the outside. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. So all of these coefficients, these are all binomial coefficients that go when we expand out x plus y to the 5th. And we could keep going forever and forever. Like this continues on and on and on, as many exponents as we want. Okay. The reason we're doing this in this unit is because I mentioned above that n choose r. So we can make this Pascal's triangle all the time, but if I ask for like specific values or specific terms or want to know certain things, we're going to have to refer back to that NCR back at the beginning. Okay, so let's do a couple examples where we expand it all the way out. So we're going to use Pascal's triangle. We can use our NCRs if we want to, and then we're going to find specific terms. So I don't want you to expand it all the way out. I just want you to find like the 5th term or the 2nd term or something like that, and then we'll move on from there. So let's go. I'll start here and I'll do an example. So this is an example of we're going to expand it all the way out. So we're going to say expand x plus y to the 3rd. So I'm kind of proving what we showed above there. Again, you can use your Pascal's triangle to find all of the coefficients, but we mentioned NCR already. So the first coefficient comes from doing 3, choose 0. The n is always going with the exponent, and then we're doing the 0 term. So it's like the 3rd exponent and it's the 0 term. It's a 0 number that we've done, I guess, so far. Okay. Then the next term will be 3, choose 1, because now I'm 1 more term over. Then we'll do 3, choose 2, and then we'll end with 3, choose 3. Now, if you plug these all into your calculator, you would find out that they match the numbers above. So I want you to try that. Do 3 NCR 0, and you get out 1. 3 NCR 1, you get 3. 3 NCR 2, you get 3. And 3 NCR 3, you also get 1. Okay. Now, to find the term, remember, I'm going to scroll back up here. When we did our x squared, y squared, the first term gets the exponent and then you decrease in value. So like we started with x to the 2nd, and then we went down to x to the 1st, and then technically we have x to the what power over here? Technically x to the 0, right? So your first term goes in decreasing exponential order. Your first term, though, or your second term, excuse me, goes in ascending order. So you're technically starting with like y to the what power in my first term? Y to the 0, right? We don't see that. Y to the 0 is the same thing as 1. That's why we don't see that. Then we have y to the 1st, and then we have y to the 2nd. So my second term is ascending in power. And so like the biggest power you can get is the exponent that's given to you. So we're going to work that out as we expand out this x plus y to the 3rd. So my first term is x. So we're going to do our descending power for x. So it's going to be x, and we're going to start with the highest power, which is to the 3rd. And I'm actually going to put this in parentheses. It's not going to matter now, but it's going to matter in a minute. So I want us to practice putting parentheses around it, okay? My next term will have x to the 1 power lower, which will be 2. My next term will have x to 1 power lower than that, which will be 1. And then my last term will technically be x to the what power? 1 minus that, which is going to be 0, which is going to be 1, which we'll cross out in a second, but just deal with me for a little bit longer, okay? Now we're going to do the y's, and that's ascending order. So the x's went down, 3, 2, 1, 0. Now as I move from left to right, I'm going to go up. So I'm going to start with 0 y's, y to the 0 power, and then each step I'm going to increase the value of that exponent. So this next one's going to be y to the first. Good. And then next it's going to be y to the second. And then last, it's going to be y to the, very good, third. So with all of this together, we've got the coefficient, and then we've got the x and the y terms, and all of these are individual terms, and then we are going to be adding them together. I want you to always think about adding them together. If there's a minus, like if any of these terms have a negative, we'll carry that with them and we'll deal with that negative there. But I want you to just think we're adding all of these terms separately. We will not be able to combine any of them because none of them will be common terms, but they're all going to be essentially added together. So as I carry them down, I've got 1 times x to the third times y to the 0. Well, that's just x to the third. Now I've got 3 times x squared times y. That just all runs together straight across. 3x squared y. Then I've got 3x to the first, y to the second, 3x y squared. We assume that the square only goes with the y, that's why it's okay to write it like that. And then last, I have 1 times x to the 0 times y to the third. Well, that's simply y to the third. Okay. Any questions so far? So first thing I did is I did my n choose r to find all my coefficients, and then I went down the order with all my specific terms, okay? Let's do another expansion. Let's try another one, a little bit longer one. So we're gonna do one that's raised to the 4th power. I'm just gonna start kind of back at the top of the page. It's gonna be kind of an ugly day of notes, but that's okay. We'll do 5x minus 2y, so I'm going to get one of those minuses in there for us, to the 4th, and we are expanding this out. So let's see, move that over. We'll write expand right here. Expand it out, okay? First thing I'm going to do is I'm going to do my coefficients. So I'm going to do all my NCRs. 4 is my highest power, so we go NCR starting at 0, and we build all the way to the biggest number, so that's 4. So we'll do 4C0, we'll do 4C1, we'll do 4C2, we'll do 4C3, and we'll do 4C4. So now I have 5 terms here. I know it's only raised to the 4th power, but there are 5 terms here. All right, we can throw these in our calculator, or we can use our Pascal's triangle. 1, 4, 6, 4, 1. Okay, those are all my coefficients. Now I have to do all my terms. So we're going to do the first term, and we're going to go in descending order. So we start with to the 4th, we bring it all the way down to the 0. And this is why I put parentheses around it, because I'm doing 5x all raised to the 4th. Not just x to the 4th, I'm also going to have to raise 5 to the 4th in a little bit too, not just x. So that's why it's all in parentheses. Okay, I'm going to keep going. Now we're going to do 5x to the 3rd. 5x to the 2nd. Yeah, okay, that's right so far. 5x to the 1st, and then technically 5x to the 0, which we are going to write for practice right now. If you feel like you're too cool for school and you're not going to mess it up, I guess you don't have to write it because it's just equal to 1, but I'm going to keep writing it to remind us it still exists. Okay, now we're going to do the second one. So, sorry, I'm trying to color coordinate here for us. Now we're going in ascending order. I'm going up as I go across the page. I'm going to keep that negative with it. I'm going to incorporate not just the 2y, but the negative 2y with everything so I don't lose him later on. So I'm going to have negative 2y to the what power to begin with? Yep, the 0. Now I'm going to do negative 2y to the, yes, ascending, add 1 each time to the first. I did not leave a lot of space. Sorry, it's kind of squished. Negative 2y to the second. Negative 2y to the third. And then last is going to be negative 2y to the fourth. Don't forget we're adding up all of these terms together. Plus, 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 plus. And then they all go together. I've got 1 times all of that, and I have 4 times all of that, etc., etc. So now I'm going to go one step farther, and I'm going to start simplifying. Before I do my multiplying the 1s, 4s, 6, etc. in, I'm going to try and simplify these terms as much as possible. So we know it's going to be 5 to the 4th. So what is 5 to the 4th? Yep, they're in your calculator, 625. X to the 4th. And then that negative 2y to the 0 just becomes 1. So I'm just going to keep it there. Then I've got a coefficient of 4. 5x to the 3rd. 5 to the 3rd is 125. X to the 3rd is just x to the 3rd. And then negative 2y to the 1st is just negative 2y. Okay, keep rolling. This one's raised or has a coefficient of 6. 5x to the second is 25x squared. Negative 2y to the second. Negative 2 squared is going to be a positive 4. Y squared is y squared. We hanging in so far? Okay, 2 more terms. Now this one has a coefficient of 4. 5x to the first is just 5x. Okay, that's easy. Negative 2y to the third. Negative 2 to the third is going to be negative 8. And then y to the third is y to the third. And then last, coefficient of 1, 5x to the 0 is just 1. And then negative 2y to the 4th. Negative 2 to the 4th is going to be 16, positive 16. Y to the 4th is just y to the 4th. All right, now I'm going to multiply everything together. So 1 times 625x to the 4th times 1, 625x to the 4th. My next term is going to be 4 times 125 times negative 2. So I'm going to throw those in the calculator. 4 times 125 times negative 2. So I'm going to have a negative number next. That's going to be negative 1,000 x to the third y. Then I'm going to do 6 times 25 times 4. That's going to be a positive number. That gives me 600 x squared y squared. 4 times 5 times negative 8. That's going to give me a negative number, negative 160 x y to the third. And then last, 1 times 1 times 16 is just a positive 16 y to the 4th. So all of this is the expanded version of that. Whew, crazy. All right, any questions, any thoughts? Let me know, or pause and rewind if you need to. Okay, if I'm looking at this example, can you tell me what the second term is? What's the second term, number 2? Yep, it's this guy right here. What if I ask for the 5th term? Yes, that's the last one. What I'm getting at is I could ask you for one specific term and then I don't need the rest of this. So you don't have to do the whole workout. We can only find one of those terms if we do a certain method or if we only focus on a certain part of this whole expansion, okay? So that's the next couple examples we're gonna do. All right, I'm just gonna roll right underneath that. Okay, so example. We're going to find the 5th term of this binomial, x plus y raised to the 11th. I'm sure as soon as I told you can find the second or the fifth term, you're like, oh, I'll probably just do it all the way out. Well, what if I throw you to the 11th power? Man, I don't want to sit there all day and do the 11th power. Instead, I'm going to do a shortcut to only do one term. I don't want to find all of it. I just want to find that fifth term. All right, if we go back to the beginning and kind of look at some common patterns that we see, like on this first one, we did x plus y to the third. It's your exponent, and then it's like the term that you're in. I guess we can think of that more specifically as term minus one, because there's technically no zero term, so I apologize for that nonsense I said earlier. So whatever term number I give you, it's minus one. So like if I said on this one, find me the third term, we would do term minus one. So I would do this choose number. Same thing on the one we did before. If I said find the fifth term here, we would do 5 minus 1, which would be this guy. So you do the exponent that's given to you, it should match up, and then the term number minus 1 is your r. So n choose r, exponent, choose, term minus 1. I'm going to write that down here just for us to think about it. N choose r, n equals exponent. Whoa, come back. There we go. R equals term minus 1. So that might be something to make note of if you don't think of that off the top of your head. Okay, so if I'm talking about this fifth term, we're going to do 11, because that's my exponent, choose, and then term minus 1. It's not going to be 5, it's going to be 5 minus 1, which is 4. Again, exponent, term minus 1. I can't say it enough. Okay, that's going to give you the coefficient. This gives you the coefficient. So like if you're thinking about up here, it gives you like the Pascal triangle. It gives you like 1, 5, 6, 10, etc. However, we know that's not all of it. Like you don't have 1, 4, 6 in this example above, right? We've got 625. It's because when we raise these numbers to a certain power, there might be other coefficients. So we got to do all of the whole term, not just this, the n choose r. Okay, so this is my coefficient. My x will be raised to what power? And then my y will be raised to what power? So remember, my x is decreasing each time. If I start with x to the 11th, my next term is going to be x to the 10th. That's my second term. My third term will be x to the 9th. My fourth term will be x to the 8th. And my fifth term will be x to the 7th. So my exponent I want here is 7. Okay, because we're in decreasing order. Now if I do y, we're in increasing order. So I normally start on y to the 0, and then I go y1, y2. What term am I at now? 1, 2, 3. Okay, I got 2 more. Y3 is my fourth term. Y4 is my fifth term. Do you see how none of these have a coefficient of 5? It could have a coefficient of 5 and be the fifth term. I'm not saying that it never is. I'm just saying you have to know where these numbers come from. So take a second, think through it, go backwards. If you can find another little cute pattern, go for it. But this is the easiest way I think of doing it. Okay, so now let's figure out what these numbers are. So when I do 11, choose 4 in the calculator, I get out 330. If I do x to the 7th, does that change my number at all? Does it change a constant in front? Any coefficient change? Nope. What about y? Nope, not today. So 330 is the best number I can get. Y to the 7th, or sorry, excuse me, x to the 7th, y to the 4th. Here's my answer. Cool. I got one more example. This time we're finding the 6th term of something. You can just do it right under here. Example. Find the 6th term of, and this time I'm going to give us a bigger expression, 5a plus 3b to the 10th. Again, I gave you a big enough number that we don't want to do it all out. We just really want to find the 6th term. So if I'm looking for the sixth term, we got to think about a couple things. First is the coefficient. We have to do n, choose r. N is the exponent, and r is the, term minus 1. So if I'm doing my exponent, it's 10. Choose term minus 1. 6 minus 1 is 5. So this is going to be my coefficient here, okay? Then I have to do my first term in decreasing order. So I'm going to do 5 times a raised to the what power? I'm going to be in the sixth term. I'm going backwards. You don't even have to write out 5a every time. I'm just going to do, it'll be the 10th power, then it'll be the 9th, 8th, 7th, 6th. What number am I? 1, 2, 3, 4, 5. One more. 5. It will be the 5th power and the 6th term. So I'm going to say 5 right there. And then my next term, my second one is in ascending order, increasing order. So times 3b raised to the, and this time I'm increasing. So I start at 0. 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, one more. Oh, it's also the 5th. Well, that's cute. Cool. Do you see how I had to work that out? Again, if you see a pattern, use it, but you can't just always use a certain number just because it says it. None of them were 6. It just didn't happen out this way, okay? Look at your math. All right, so let's do these things. 10 choose 5 is going to be 252 in the calculator. And I got to do 5a to the 5th and 3b to the 5th. So 5 to the 5th, if I throw that in my calculator, I get 3,125, and then a to the 5th just stays the same. And then when I do 3 to the 5th in the calculator, I get 243, and then b to the 5th just stays the same. Now I have to multiply these giant numbers together. You're gonna get some wild answers here. This number times that number times that number. A big crazy number is not necessarily wrong. I'm not gonna say it's always right because there are easier, smaller numbers we got. Like this example had smaller numbers. This example had some normal-ish numbers. So just don't always assume it's gonna be crazy, but if it is crazy, that doesn't mean that it's wrong. When I multiply these 3 numbers in the calculator, I get this huge number, and don't forget your a to the 5th, and don't forget your b to the 5th. Whew, okay, those are lots of good examples. So check out your homework. If you need me, let me know. I'd love to help you. Again, this is section 9.2, so you can check that out in your book if you need extra help or need extra practice problems. Bye.